Okay, now we're down to the last question. Okay, so it's a 2 kg metal box, so this is the mass that's given. Resting on a rough horizontal surface, since it's rough, most probably there'll be friction. Okay, it says a force is applied on the box as shown, so it's applied towards the right. The force F varies with time according to the graph shown in figure 13.2. So it's over here. The corresponding speed time graph is shown in 13.3, shows the effects of the force. So now, let's look at 13.2 first. We know that in the first 3 seconds, a force of 4.0 Newton is applied. From 3 to 5 seconds, the force increased to X Newton. Okay, so this is in terms of the force applied. Now let's look at the speed time graph. In the first 3 seconds, when the force is 4 Newton, the speed is 0. So we know that the speed is 0. But from 3 to 5 seconds, when the force increased to X Newton, okay, you realize that the speed is increasing. Means that there is an acceleration. So acceleration, yes, there is. Okay. Now let's look at part 1. It says, calculate the resultant force acting on the metal box during the first 3 seconds. So we know that the speed is 0 meter per second. We also know that acceleration, because the speed is not increasing, would also be 0 meter per second squared. So using F equals to ma, we know that the metal box is 2.0 kg, but the acceleration is 0, so we know that the resultant force will be 0 Newton. So resultant force, 0 Newton. Now, they ask us to calculate the frictional force acting on the box. We know that the pushing force minus the friction must be equals to the resultant force. Okay, so the push we know is 4.0 Newton. Okay, but the friction is the one that we want to find. So 4.0 minus friction, we know the resultant force is 0. So friction must be equals to 4 Newton, 4.0 Newton, 4.0 Newton. Now they ask us to calculate the distance traveled by the box during the first 5 seconds. So you look at this whole question here. Since the speed time graph is given, we will use the distance traveled equals to area under a speed time graph. Okay, so if you look at this whole graph over here, let's use a green color to annotate. The only area that we have here is over here, right? This triangle. Now for this triangle, right, for this triangle over here, we realize that it's a triangle. The base is 2 seconds, the height is 6, so equals to half times 2 times 6. What we're going to get is 6 meters. So the distance traveled is 6.0 meters. Do take note, your answer should be 2 or 3 SF. Maybe I should put the frictional force as 0.0 just to show that it is 2 SF. Alright, 2 or 3. Now, in part 4, they ask us to calculate the acceleration of the box from 3 to 5. So the interval here is 2.0 seconds. To find acceleration, I'll use v minus u over t. So the final speed is 6, the initial speed is 0, the time difference is 2 seconds. So v minus u is 6 minus 0 divided by 2 seconds. I'll get 3.0 meter per second squared. 3.0 meter per second squared. That's acceleration. Find the value of the force X as indicated in 13.2. Because, okay, do take note, friction will still remain the same because it's still on the surface. It is 4.0 Newton. Okay. X is actually the pushing force. So we know that the resultant force first. Okay, let's find the resultant force, which can be calculated with m times a. So 2 multiplied by 3, we know is 6.0 Newton. We know that the push, which is X, minus friction, must be equals to the resultant force. So the push is X, friction we know is 4.0 because it's still on the same surface, and we know that the resultant now is 6.0. Therefore, X must be equals to 10 Newton. So final answer, X is 10 Newton. Okay, let's go on to 13b, the next page. Okay, a block of wood with a weight of 60 Newton rests on an inclined plane as shown. There's a reaction force of 52 Newton acting on the block. Determine by means of a vector diagram on the grid the magnitude of the resultant force on the block of wood. Okay, so uh, this one we need to use protractor. So I'm a bit concerned now because I do not have a protractor. Okay, so just to roughly share how to go about doing it, I'm not gonna draw it to scale, okay, but I'm gonna like roughly show it. So you can see here this is 6 units. So this 60 Newton is actually 6 units. Right? Now if you look at this whole diagram over here, you realize that this angle here is actually 180 minus 30, so it's 150 degrees. So I'm gonna measure 150 degrees, measure 150 degrees, okay, and I'm gonna draw 5.2 units long, okay, okay, so this is 52 Newton, which is 5.2 units long. Now, just remember, this whole thing here is not drawn to scale, okay, not drawn to scale because I do not have a protractor with me now, okay, but just want to draw something like this, okay, so measure 150 degrees, measure 5.2 units, and then draw the 52 Newton there. Now, I'm going to show you the parallelogram, okay, the parallelogram method. So what I'm going to do now is, I'm going to measure 30 degrees. So to do a parallelogram, the angle over here I'll measure is 180 minus the center angle, which is 150. So this will be 30 degrees. So I'm going to draw a dotted line like this. Okay, draw a dotted line, draw it long. Next, I'm going to measure 30 degrees over here. 30 degrees. I'm going to draw another line like this. Okay. Now the point where it from the starting point, the point where it intersects, okay. So this is the resultant force. You just need to measure the units. So then that will be equivalent to the Newton. So 1 unit represent 10 Newton. So depending on what is the number of units over here, okay, it will be the resultant force there. Okay, so for your vector diagram, do take note to draw it accurately. Okay, it must be drawn to scale. Okay, so that's all.